Since 2007, Anoplotherium is thought to have been a quadruped capable of standing on its hind legs for browsing, supported by a strong pelvis, robust tail and splayed hind legs. Its bipedal adaptations show convergence with animals like calicotheres, ground sloths and the gerenuk. The overall body form resembles that of the Canidae. While standing bipedally, its neck and head could remain horizontal, and forelimbs could extend beyond the snout but were not used for ripping plants. Anoplotherium's large size and bipedal browsing ability reduced its competition. Researchers suggest it might have engaged in niche partitioning with other Eocene browsers. Criticism exists regarding some morphological evidence, with studies questioning its bipedal adaptations based on trabecular architecture. Footprint patterns indicate it might have walked in small, sociable groups. Anoplotherium was amongst the largest non-whipomorph artiodactyls of the Paleogene period, weighing on average 120 to 270 kilograms. It was an evolutionarily advanced and unusual artiodactyl, a long and robust tail and a highly developed brain with strong support for both sense of smell and sensory perception. Diplobune was a medium to large-sized Anoplotheriide similar to Anoplotherium, but with specialized three-fingered limbs and unique dental, postcranial and brain anatomy. It was adapted for a florivorous diet, with dentition suited for chewing hard leaves and possibly had a tapered tongue for reaching branches. Its limbs, unlike any modern analogues, had powerful muscles for mobility, particularly in bending its fingers, suggesting some level of arboreal or semi-arboreal behavior. This set it apart from Anoplotherium and other contemporaneous mammals. Diplobune lived in Western Europe when it was an isolated archipelago, evolving in an environment with high levels of endemism. It thrived after the shift to drier conditions and survived the Grande Coupure extinction event, though it lost at least one species. Cainotherium is an extinct genus of rabbit-sized prehistoric even-toed ungulates. These herbivores lived in Europe from the Eocene until the early Miocene. The skeletal anatomy of these hare-like animals suggests they, along with other members of Cainotheriidae, belong to the artiodactyl suborder Tylopoda, together with oreodonts and modern camelids. Species had cloven hooves, similar to those of bovids or deer, although the shape and length of the limb suggests that the living animals moved by leaping, like a rabbit. The shape of the teeth also suggests a rabbit-like diet of nibbled vegetation, while the size of the auditory bulla and shape of the brain suggest that it would have had good senses of hearing and smell. Diacodexeidae is the oldest known even-toed ungulate. In life, it would have resembled a modern duiker, measuring about 50 centimeters in body length, but with a much longer tail. Unlike most later species of artiodactyl, it still had 5 toes on each foot, although the third and fourth toes were already elongated. It may also have had small hooves on each toe. Its teeth suggest that it was a herbivorous browser. As suggested by its long legs, Diacodexeidae is believed to have been fast-running, capable of leaping relatively far. Xiphodon is also the only xiphodontid to be represented by known postcranial fossils. Its skull morphology combined with slender and elongated limbs might suggest similar behaviors to North American Paleogene camelids, including cursoriality. However, the full extent of its behavior and evolutionary relationships remains uncertain, its resemblances to camelids probably being an instance of convergent evolution. It lived in Western Europe back when it was an archipelago that was isolated from the rest of Eurasia, meaning that it lived in an environment with various other faunas that also evolved with strong levels of endemism. The xiphodont made its first appearance in the Middle Eocene shortly before a shift towards drier but still subhumid conditions, which led to increasingly abrasive plants. Along with being the oldest camel known, Protylopus was also the smallest, reaching a length of 80 centimeters, and probably weighing around 26 kilograms based on its teeth. it probably fed on the soft leaves of forest plants. Protylopus's front legs were shorter than the hind legs, and ended in four-toed feet. The hind legs also ended in four toes, but most of the weight was carried by the third and fourth, so it may have raised itself up on its back legs like the modern-day Gerenuk antelope to feed. The shape of the toes suggests that the animal possessed hooves, rather than the foot pads of modern camels. Merycoidodon would have somewhat resembled a pig in appearance, but had a longer body, at about 1.4 meters, and short limbs. The fore limbs had 5 toes, while the hind limbs had 4. Given the shape of the limbs, it is unlikely that the animals would have been able to run fast. Unlike modern ruminants, they had a full set of teeth, although the molars were adapted for grinding up tough vegetation. Notably, they had strong, and very striking, canines. The skulls of Merycoidodon have a pit in front of the eyes. Similar pits are found in the skulls of modern deer, where they contain a scent gland used for marking territory. Although it was not directly related to deer, it seems likely that it possessed a similar gland, which may imply that it, too, was territorial. Oreodonts lived in large herds and moved about from place to place. These animals would have looked rather pig or sheep-like, but features of their teeth indicate they were more closely related to camelids. They were most likely woodland and grassland browsers, and were widespread in North America during the Oligocene and Miocene. The 1-meter-long Brachycrus resembled its bigger, earlier relative Merycoidodon, but was more specialized. It had jaws which were short, and because the nostrils were placed far to the back, the creature is presumed to have had a taper-like proboscis. Camelus was a prairie dweller of North America. It was a highly specialized animal. Its head was relatively small compared with the rest of its body, its neck was long, as a result of giraffe-like lengthening of the cervical vertebrae, and its legs were long and stilt-like, with the elbow and knee joints on the same level. The top of its head was about 3 meters above the ground. Its strange body structure gives information on its mode of life and habits. It obviously inhabited dry grasslands with groups of trees. It is presumed to have moved about singly or in small groups, like today's giraffes, and like them, browsed high up in the trees. In this respect, it had no competitors. It survived a relatively long time, through most of the Miocene epoch, and died out prior to the start of the Pliocene, possibly due to climatic changes. Procamelus had long legs designed for speed, and was about 1.3 meters in height at the shoulder, slightly smaller than a modern llama. Unlike modern camelids, it had a pair of small incisor teeth in the upper jaw. The remaining teeth were large and adapted for eating tough vegetation. The shape of the toes suggests that it possessed foot pads, like modern camels, unlike earlier forms of camelid, which generally had hooves. This would have helped it walk over relatively soft ground. Titanotilopus is distinguished from other early large camelids by its large upper canines amongst other distinguishing dental characteristics, and absence of lacrimal vacuities in the skull. Unlike the smaller, contemporaneous camelops, Titanotilopus had relatively broad second phalanges, suggesting that it had true padded camel toes, like modern camels. It possessed long and massive limbs, a comparatively small brain case, and a convex slope between the eyes. It reached a shoulder height of 3.5 meters and a weight of 2,500 kilograms like modern camels. It possessed a hump for fat storage. Evidence for this is provided by the long neural spines on its thoracic vertebrae. Camelids are unusual in that their modern distribution is almost the inverse of their area of origin. Camelids first appeared very early in the evolution of the even-toed ungulates, around 50 to 40 million years ago during the Middle Eocene, in present-day North America. The original camelids of North America remained common until the quite recent geological past, but then disappeared, possibly as a result of hunting or habitat alterations by the earliest human settlers, and possibly as a result of changing environmental conditions after the last ice age, or a combination of these factors. Because soft tissues are generally not preserved in the fossil record, it is not certain if camelops possessed hump, like modern camels, or lacked ones, like modern camelids of South America. One-humped camels are now known to have evolved from two-humped camels, but two humps, as an evolutionary outcome, likely associated with Arctic climates, and two-humped camels presumably evolved into one-humped camels in warmer regions in Eurasia, while camelops first appeared in southern North America and lived among both warmer and colder regions of the continent until early Holocene. It had legs 20% longer than that of the dromedary, and was about 2.3 meters tall at the shoulder and weighed about 1,000 kilograms. Camelops probably could travel long distances, similar to modern camel species. Whether or not camelops could survive for long periods without water, as with extant camels, is still unknown. This may have been an adaptation that occurred much later, after camelids migrated to Asia and Africa. The dromedary is diurnal, feeding and roaming during the day while resting at noon and through the night. They form cohesive groups of about 20 individuals, usually led by a dominant male, with females sometimes taking turns leading. Some males form bachelor groups or roam alone. During migrations, herds may congregate into larger groups of hundreds. Dromedaries have special behaviors such as snapping without biting and stamping feet to show displeasure, and they generally avoid aggression except during the mating season. Their diet consists mainly of foliage, dry grasses, and thorny plants, and they are primarily browsers. They have adapted to desert life with features like bushy eyebrows, double-row eyelashes, and the ability to close their nostrils. Dromedaries can tolerate significant water loss and rehydrate quickly, storing up to 40 kilograms of fat in their humps for energy. Their padded hooves are suited for desert terrain but not for slippery surfaces. The dromedary was probably first domesticated in the Arabian Peninsula about 4,000 years ago, or in Somalia, where there are paintings in Lascaux that figure it from 5000 to 9000 years ago. In the wild, the dromedary inhabited arid regions. The domesticated dromedary is generally found in the semi-arid to arid regions of the Old World, mainly in Africa and the Arabian Peninsula, and a significant feral population occurs in Australia. Siberian camel is one of the largest known species of genus Camelus, being considerably larger than the 3 living camel species. It has been estimated to reach around 3 meters tall and over 1,000 kilograms in weight. Its bones are more physically massive than those of living camels. The facial part of the skull is around 60% of the total length, somewhat elongate relative to other members of Camelus. The latest remains of the species are from the Gobi Desert of Mongolia, where the species became extinct around the last glacial maximum. Genetic analysis suggests that the species had already been in population decline for tens of thousands of years prior. The species likely went extinct as a result of unfavorable environmental change, including the aridification of the Gobi Desert around this time. Bactrian camels are exceptionally adept at withstanding wide variations in temperature, ranging from freezing cold to blistering heat. They have a remarkable ability to go without water for months at a time, but when water is available, they may drink up to 57 liters at once. When well fed, the humps are plump and erect, but as resources decline, the humps shrink and lean to the side. When moving faster than a walking speed, they pace, by stepping forwards with both legs on the same side. Speeds of up to 65 kilometers per hour have been recorded, but they rarely move this fast. Bactrian camels are also said to be good swimmers. The sense of sight is well developed and the sense of smell is extremely good. The lifespan of Bactrian camels is estimated at up to 50 years, more often 20 to 40 in captivity. As pack animals, these ungulates are virtually unsurpassed, able to carry over 200 kilograms at a rate of 47 kilometers per day. Furthermore, Bactrian camels are frequently ridden, especially in desertified areas. Like its close relative, the domesticated Bactrian camel, it is one of the few mammals able to eat snow to provide itself with liquids in the winter. While the legend that camels store water in their humps is a misconception, they are adapted to conserve water. However, long periods without water will result in a deterioration of the animal's health. They are primarily herbivorous. With tough mouths that can withstand sharp objects such as thorns, they are able to eat plants that are dry, prickly, salty, or bitter, and can ingest virtually any kind of vegetation. When other nutrient sources are not available, these camels may feed on carcasses, gnawing on bones, skin, or various different kinds of flesh. Camels face various threats including poaching, climate change, being hunted, and human encroachment into their habitat. Hunters kill the camels by laying landmines in the saltwater springs where the camels drink. Other threats include scarcity of access to water such as oases, attacks by wolves, hybridization with domestic Bactrians leading to a concern of a loss of genetically distinct populations or infertile individuals which could potentially ward off viable bulls from a large number of females during their lifetimes, toxic effluent releases from illegal mining, redesignation of wildlife areas as industrial zones, and sharing grazing areas with domestic animals. Guanacos stand between 1 and 1.3 meters at the shoulder and weigh 90 to 140 kilograms. Their color varies very little, unlike the domestic llama, ranging from a light brown to dark cinnamon and shading to white underneath. The lifespan of a guanaco can be as long as 28 years. They are one of the largest terrestrial mammals native to South America today. Guanacos are often found at high altitudes, up to 4,000 meters above sea level, except in Patagonia, where the southerly latitude means ice covers the vegetation at these altitudes. For guanacos to survive in the low oxygen levels found at these high altitudes, their blood is rich in red blood cells. When threatened, the guanaco alerts the rest of the herd with a high-pitched bleating sound, which sounds similar to a short, sharp laugh. Though typically mild-mannered, guanacos often spit when threatened, and can do so up to a distance of 2 meters. The guanaco can run up to 65 kilometers per hour. This speed is important for the survival of guanacos because they cannot easily hide in the open grasslands of the Altiplano. Llamas are social animals and live with others as a herd. Their wool is soft and contains only a small amount of lanolin. They can learn simple tasks after a few repetitions. When using a pack, they can carry about 25 to 30% of their body weight for 8 to 13 kilometers. The ancestors of llamas are thought to have originated from the Great Plains of North America about 40 million years ago, and subsequently migrated to South America about 3 million years ago during the Great American Interchange. By the end of the last ice age, camelids were extinct in North America. In Aymara mythology, llamas are important beings. The heavenly llama is said to drink water from the ocean and urinates as it rains. According to Aymara eschatology, llamas will return to the water springs and ponds where they come from at the end of time. Alpacas are visually and genetically similar to, and often confused with, the llama. However, alpacas are visibly shorter and are bred predominantly for their wool, while llamas have long been more highly prized as livestock guardians, and as a pack animal, owing to their nimble mountain climbing abilities. Nonetheless, all 4 South American camelids are closely related and can successfully crossbreed. Both the alpaca and the llama are believed to have been domesticated and selectively bred from their wild counterparts at least 5,000 to 6,000 years ago. In the textile industry, alpaca primarily refers to the hair of Peruvian alpacas, but more broadly it refers to a style of fabric originally made from alpaca hair, such as mohair, Icelandic sheep wool or even high-quality wool from other breeds of sheep. The vicuña is considered more delicate and gracile than the guanaco, and smaller. A key distinguishing element of morphology is the better developed incisor roots for the guanaco. The vicuña's long, woolly coat is tawny brown on the back, whereas the hair on the throat and chest is white and quite long. The behavior of vicuñas is similar to that of the guanacos. They are very shy animals, and are easily aroused by intruders, due, among other things, to their extraordinary hearing. Like the guanacos, they frequently lick calcareous stones and rocks, which are rich in salt, and also drink salt water. Vicuñas are very clean animals, and always deposit their excrement in the same place. Their diets consist mainly of low grasses which grow in clumps on the ground.